Alright, so lesson 5-6 is graphing proportional relationships. So remember what you did before is they gave you a table, you had to like fill out the rest of the table? Remember? Okay, so we're going to be doing stuff like that today, and then we're going to be taking that and we're going to be graphing it, putting it onto a graph, a line graph. So you had to know how to do, let's say, like last Monday's to be able to do today's. So first thing, let's have a little review. We talked about this the other day. Some ways you can tell if something's in proportion. Do you remember? I gave you like 3 or 4 different ways you can tell if something's in proportion. Hannah? Yep, you can reduce, remember? And then a whole thing will be in proportion if it reduces to the same thing. John? Okay, cross multiply or cross products. Very good. Yep, you can multiply. For example, you can say, okay, if I multiply by this by 2, I got to multiply my top to get by the same thing by 2 to get to the same number. Very good, Hannah. Divide. If I divide both and they come to the same decimal, guess what? They're proportion. So that's how many different ways you can tell. Then, this is what we did the other day. You know what? A lot of times you can reduce quicker and see quicker in your homework by just reducing. So, alright, so let's talk about this. If I have a table, what can I do to make sure the rest of this table is in proportion? I want to put this thing in proportion. What am I going to do, Hannah? Okay, so if I buy 2 pizzas, it's going to be 12. Yep. So if I buy 3 pizzas, 18, 4, 5. Okay, does everybody know how to do this? Because this is going to be a big part of your homework today. So making sure things are in proportion, creating your own tables, that's going to be part of it today. So, alright, so graphing things in proportion. Let's just talk about how to graph first of all. Okay, when you need a graph, what you're going to do, first of all, you have to have 2 axes. Remember this? Okay. So the first thing I'm going to do is they're going to give you a table, and they're going to say, I want you to graph this. Okay? If you want to put this in your notebook, you can. Just have like an example, because this is like my one really good example that I have for you today before I let you do it on your own. Okay, so we're going to graph time and distance. We can do time. Let's do, let's see, I don't know, hours, distance, miles. No. Nope. Yep. Label. You mean this part? I'll show you. If you get all those things written down, I'll go through this step by step. So time, distance, it's really slow. It's like a turtle again. For every 1 hour, he maybe goes 6 miles. I guess that's not so bad. I guess you could be running it. 1 hour, 6 miles. 2 hours, 12 miles. Once you get this stuff written, then I will show you how to do this with my graph and my table here. That's the start of my graph. The start. My graph. Okay, remember when you have a table or a graph, something's always your x and something's always your y. Remember that part? Okay, so the top is going to be on your x-axis, and your bottom is going to be on your y-axis. Okay? So that's what, because Lauren, you asked to make sure you label each axis. That's what that means. So like my x, my time is going to go down here, and my distance is going to go over here. Okay? Does that make sense now? Okay, because this is my x-axis, and this is my y. So on my y, I want my distance. On my x, I want my time. So by finding my ordered pairs for my table is very simple, because my ordered pairs are already given there for me. Here's an ordered pair, here's an ordered pair, here's an ordered pair, here's an ordered pair, here's an ordered pair. So like my ordered pair here would be 0, 0, this would be 1, 6, this would be 2, 12, 3, 18, 4, 24. Those are my ordered pairs. Pretty simple to pull those off. Now, next thing I'm going to do is I'm going to graph them. Okay, so I know my time is on the bottom, and see how my time goes by ones? Just go by ones on the bottom there, too. So, 1, 2, 3, 4, 5, and if you want to use your graph paper to start this, you can. If you use graph paper, use the lines on your graph paper. That's why they're there to help have even intervals, so you exactly know where you're going to put your dots. Use your lines on your graph paper, John. Well, if I'm going to go, see how it goes by sixes on the bottom? What could I go by on the side then? I could go by sixes. So you can go by ones if you want. You're more than welcome to go by ones. I could go by twos. I could go by sixes. Yeah, it's whatever you feel comfortable with. But here's the thing. Remember last year we talked about how you can't just go by ones and then twos and then threes and then back to ones and back to twos. Remember we talked about that last year? Your interval has to be the same. So do you see how it says ones down here? Okay, if I want to go by sixes on the side, that's fine. I'm going to go by 6, 12, 18, 24, 30. I can't go by 6 to 7 to 10 to 19 to 21. I can't do that. My interval has got to be the same. That's the only way it's going to work to show if something's in proportion. Okay? So now you go ahead and you apply your points. So 0, 0, 1, 6, 2, 12, so on and so forth. Looks something like this. And then my last one, this is when you can connect your dots. Connect your dots. Something straight, because that's going to be important here coming up. It's important to have something straight. Yes, if it's straight, right. Yes, if it's constant, it's in proportion. And if I would ask you, what's my constant? What is it constantly going up by? It's constantly going to go by 6, and we talked about that a few days ago. And if I ask you, let's say I pull this one off. Here's my point. It's 212. What does that point 212 mean in terms of what I'm talking about here? What does 212 mean, Harley? Very good. If they ask, I know they're going to do this in your homework, they're going to pull a point off, and they're going to say, what does 212 mean? And you've got to say, okay, for every 2 hours, I can go 12 miles. What if they ask you about 0, 0? What does the point 0, 0 mean? Yeah, if I don't go have any time, I'm not going to go 20 miles. They're going to pull a point off, and they're going to ask you what it means. Here's the thing. Let's say you use your graph paper and you decide you want to skip some lines. It has to be consistent. If you're going to skip a line every time, it has to be consistent. You can't say, okay, I want to skip one here and then not here and then one here and then not here. You can't do that. It has to be consistent. Does everybody understand that? Consistency is key. If you aren't consistent, your graph is not going to turn out right. I don't think so, but I will look. Okay, well then I would, I go up by fourths. Fourth, half, 3/4, 1. I would do something like that. Okay, but I don't think you'll have anything like that. So whatever ones, whatever times say yes, you can do it that way. Yep. Maybe you say, maybe like Harley said, well, I would rather like to go by twos. She can go by twos. That's fine. But your graph and her graph might not look the same. I mean, if you go by sixes and she goes by twos, that's not going to look the same. That's okay. That's okay. Okay, so a few things. This is why you need to have a straight edge. Because you asked me, why do they have to have a straight edge? Well, here's the deal. There's 2 ways you can tell if a graph is in proportion or not. Some of you might remember this from last year. If it goes through the origin. And that's why it's so important to use a straight edge, because sometimes, you know what, it might not. And it's really important to use that straight edge. So, if it goes to the origin, and it must be a straight line, you have to have both of these for it to be in proportion. That's why you have to use a ruler or something straight. Like the side of your planner, that's a nice straight edge. Something like this, that's nice. Piece of paper, that's nice. If you got a little ruler, use that. It does not matter. So now let's look at this. If I go back here and if I look at this one that I just made, is this in proportion? Yes, I know it. Straight goes to the origin. If you have something like this, is this in proportion? But it's straight. It doesn't go through the origin. It has to go through the origin. So then, let's say I have something like this. But it goes through the origin, not straight. You have to have both of them. Because they might do this to you. They might give you they might give you a picture of a graph. And they might say if this is in proportion or not. Yes. Okay. Even though be careful. You just got to remember those two things. Sometimes they might have you graph something. Let's say they give you a table like I had before, and your table starts like this. And then they say, okay, is this in proportion or not? No, it's not, because it doesn't go through that 0, 0. Even though it's straight, it's not going to be in proportion. And if they give you a table, let's say they give you a table and they tell you to graph it, you should be able to tell already if it's not in proportion. Because if it doesn't reduce to the same thing, you're going to know right away. Okay? Any questions so far? Actually, I think this is kind of fun, really. I think it's kind of easy. Oh, Virginia. Okay, so here's an example of what they're going to do for you. Okay, here's an example. They're going to say, James earns $5 per hour babysitting. Create a table and a graph, and then tell if it's in proportion, yada, yada, yada. You have to still graph it, even if you know whether it's going to be in proportion or not. Question? Well, first of all, I need to create a table. So we can do what? Hours, and then money. You can do it this way, or let's say you do it this way. Hours, money. Because they may give you a graph a different way too, my up and down, and this is just still X and this is still Y. Okay, so top is X, bottom is Y, left is X, right is Y. Okay. So now I'm going to do my hours. 1, 2, 3, 4. Money 5, 10, 15, 20. Okay. Now I'm just going to quick sketch a graph. What goes where on here? Hours on the bottom, very good. And money on the side. Now, if you were going to do your hours axis, what would you go by? I would go by ones, yep. 1, 2, 3, 4. On the side, what would you go by? I would also go by 5. Okay, and then you graph it, and it should look like this. Pretend that goes through the straight line, and it's origin, and then it goes through all the dots. Okay, it's in proportion. Pretend it does. Pretend. Yeah, proportion. Yeah. Okay, one thing I want to show you, because let's say you get to some huge, huge, huge numbers. Let's say it's like this. Let's say it starts 1, 220, 2, 225, 3, 230. That's okay. That's okay. Pretend it is. Let's just pretend it is. Now let's say I do my sides here. Now, what am I going to do on the side here? Can I start at 220? And then can I go to 225? Why not? Because what's in here? I have 220 numbers. Then how many numbers do I have in here? 5. See how it's not in or it's not in the same, it's not consistent? Do you see that? Oh, no. Let me show you a trick. Can I show you a trick? I'll show you a trick. Why can't you do that? Okay, so because if I start at 220, then my next one should be 440. See how this goes up by 220? My next one should be 440. My next one should be 660. To stay in proportion, that's how it should be, right? But let's say this is how my graph is, and I go to start at 220. I can't go to 225 because in here, it's 1 through 219. Now it's here, it's 220 through 225 or whatever. See what I mean? See how there's only like 5 numbers here and there's like 200 and some here? That's why I can't. It's not consistent. Okay? Good question, because I know I'm going to get a lot of that. Let me show you a little trick. You want to see a trick? This is called, I don't even know what this is called, but it's something you can use in math. So let's say I need to start my graph at 220. I can do this little thing. Has anybody seen that before? It's basically like a break in the graph. Now I can start at 220. Now I can go to 225. It's a break in the graph. You don't have to write the whole thing. So like what happened is you wrote the whole thing, you cut out the middle part, and you made it smaller. What? Now I can start at 220 because this little break shows me that you have the whole graph there, but it's just condensed so I don't have to make it go off the page. Yep, it's a squiggle. John? Yep. it going by 5. Because if I would do the next, it would be 230, 235. Yeah, so it went up by 5s in here. But think of how long that would take me to get to 225. A long time, right? So what I did is I basically cut that part out and I made it smaller. So it's like it's there, but it's not really there in my graph. Yeah, that's why this thing, that's what that means. Get it? Okay. Will you graph this for me? This one thing I'm going to ask you to graph, and then I'll let you work on your homework. You can just sketch it. Yes. Yep. Yep. And Lauren, if you get confused on that, you guys, this is for anybody. If you get confused what goes where, it's okay. It's okay. It's just a lot of times if you're going to go by ones, that usually goes like on the bottom. Makes it easier. It's okay. Your graph is just going to look different than somebody else's. Your graph is just going to look different from somebody else. You're confused about. Oh, I would 1, 2, 3, 4. As long as you skip the same amount of lines. Yep. That's okay. Okay, so what's up with you? Good. Nice job. No, that's right. Time on the bottom. That's fine. And then, so you want to do cost on the top. You can go by 5s. Yep. Okay, now make sure you graph them. Okay, then use a straight edge to make a line. Okay, where's yours at? Okay, for some reason yours didn't turn out, and you know why? It's because you didn't skip an extra line here. Should have been 1. We need to skip an extra line here. Oh, sorry. Yes, that's okay. So we need to skip an extra line, because then it would end up like
and
that.
An extra line here.
Yep, probably. Yep. So if you skip, see how you skip, you only went up to 1, guys.
And I should skip this line.
Yep. Good. Now we're on the same page.
I'm just keeping this line.
Sometimes that's easier. Sometimes that's easier. Huh? Okay, so if you look at your graph, it should be in proportion. It should not go through the origin. If it does, that means there's something wrong with your spacing. Yes. Yep. So like even this one, you could say this is in proportion, except for if 1 hour is $10, 2 hours should be 20. So just because you look at that one doesn't mean it's yes or no. You got to look at the next few to figure it out for sure if it's going to be. Because I know 2 hours should be $20, 3 hours should be 30, 4 hours should be 40 if it's consistent. So if you're going through the origin and it looks like it's in proportion, it's something to do with your spacing. Like we were up here looking at hers, and her spacing is off by just because she didn't skip one more box. She didn't skip one more line, and that's why. So you have to be careful with your spacing. If you are just putting anything you want on your graph, it's always going to be in proportion every single time. Because watch, let's say if I graph this, and let's say I don't care about my, here's my graph, 1, 2, 3, 4. And let's say, oh, I'm not going to worry about my, what do you call it? My spacing or my intervals. And I just say, okay, this is 10, this is 15, this is 20, this is 25. Well, look what's happening. It's automatically, every time it's going to be in proportion. So you have to be careful with your spacing. That's what's going to tell you if it is or if it's not. Because if you put whatever you want up there, it's not going to work out. Okay? You have to be careful. Any questions for me? Okay, open your books because I'm going to talk about